Hello and welcome to my YouTube channel. Today in this video we are going to see how to make the onboard LED of Nucleo F44 6RE microcontroller board blink using STM32 Cube IDE. This is the first program that we are going to develop under this playlist. So how can we make the LED blink using STM Cube IDE? So for that we have to follow few steps. First of all, we will open the STM Cube IDE and then we will download the user manual of the microcontroller board. In our case it is STM32 F44 6RE microcontroller board. If you have any other board, just download the user manual and check where the onboard LED is connected. Then after that we can write the program for that particular board and run the code to check if we have made a correct program or not. So without any delay, let's open the STM Cube IDE. In this case, I am going to start a new project in the STM Cube IDE. It will take maybe a couple of seconds to open the Cube IDE. Now you can start or create a new project by going to File, click on New and then STM project. The IDE will take further few couple of seconds to initialize the target and the board related libraries. Now here you can select the microcontroller that you have, or you can select the board you want to work with, or you can select an example, or you can select cross selector. That means you have developed a project in one microcontroller, but you want to transfer the same code to similar microcontroller with different numbers. In our case, let us start from the board selector and just type Nucleo F44 6RE and we can see the board is present here in the right side bottom. First, let us download the data sheet or reference manual. For that you can go to Docs and Resources on the top, then scroll it down and then at the last you can see user manuals. Click on the user's manual and then select UM1724. I am downloading the user manual for Nucleo F44 6RE microcontroller board. You can select any other microcontroller board that is with you and download the user manual. So let us click on the user manual and here in the user manual you have to go through the user manual and check where the onboard LED is connected. In our case, you can see here user LED 2, that is the green LED is a user LED connected to Arduino signal D13 corresponding to STM32 IO PA5, that is pin number 21. So here our target is PA5 and we can start writing the code for blinking the LED which is connected at PA5. So in this way you can go through the data sheet or the user manual and figure out which port or pin you have to work with. Similarly, you can explore more details about the pins which are connected to your UART or USART. Apart from that, the pin diagram of your microcontroller board and so on. So this is a very good feature of STM Cube IDE From here itself you can download all the relevant documents, technical notes, schematic and everything. So now let us start the project. So click next, and here let us give a project name blink underscore onboard underscore LED, and click next and finish. So it says initialize all peripherals with default mode. You can select yes or no based on your choice. Right now I am going for no. So I am not going to initialize all the peripherals which are there in my board. Now the project will be created using the minimum requirements for the STM microcontroller board. So let me take further couple of seconds to allow the software to initialize all the required peripherals. Here we can see the STM Cube MX perspective. On the right you can see here you have C or C++ perspective, Cube MX perspective or debug perspective. Depending on your choice, you can switch between these perspectives, and right now by default STM Cube IDE has started the Cube MX perspective. Now let me just go to pinout and clear all pinouts so that we can start the project from the scratch itself. You can use the mouse rollover to zoom in or zoom out, and here as we know our LED is connected to PA5. I will go to the PA5, right click on that, left click on that and scroll down and make it GPIO output. So now we have declared PA5 as an output pin, and now right click on enter user label and give it a name, for example LED, and click enter. So we have defined PA5 to work as an output port, and we have given a name LED to that pin. Coming to the system core, here you can select the system and connect serial wire if required, or you can leave it. No compulsory, because it is not compulsory here, because we are not going to work with any serial port or serial communication right now. Then we have RCC, where you can select the high speed enabled clock and low speed clock, and you have two options. You can use bypass clock source or crystal ceramic resonator. Right now I am not going for any bypass clock or resonator. Just close this section and let us look into the clock configuration. Here in the clock configuration you can see by default LSI is selected and HSI is selected at 16 MHz. You can come to the right side and you can see system clock is running at 84 MHz, and you can see all the peripheral buses which are getting different clock speeds. In future we will be discussing about how to select or change these values so that you can get different clock rates for different peripherals, and how to know which peripheral is connected to which bus. So all these will come, or we will discuss in the upcoming videos. Right now we don't have to worry about this part, so we can just click here to generate the code. Okay, or you can just save the project and it will automatically generate the code. So I would prefer to save the code. And here you can see, do you want to generate code? You can click yes, and the code will be generated, and automatically you can see the system has, or cube ID has changed to C or C++ perspective. Before it was in the CubeMX perspective, now it is in C and C++ perspective. Here we have the code which is generated by the CubeMX. So all the important peripheral initialization has been generated. For example, clock configuration has been done, GPIO initialization has been done. We have the main program, hall initialization, system clock configuration. All these has been automatically generated by the CubeMX. So you can clock this part. You can check what are the GPIO's initializations. So here we have LED GPIO port, LED pin. By default it is in reset mode. Then the pin has been named LED pin. Mode is output mode, and no pull up or pull down. Speed is low frequency. So this has been initialized. In future we can see how can we change these parameters, but right now we don't have to worry about this part. So I will just close these parts so that the program will look smaller. Now remember, you should write your code in the sections where it says user code begin, between the section user code begin and user code end. Otherwise, whenever you make any changes in the CubeMX perspective, okay, and generate the code, all the codes which you have developed previously will be cleared. So please remain within this section whenever you write your own code. So here, now let us open the core folder in the left, Project Explorer, click the source, and here you can see the main file is there. Apart from that, you can open the drivers, click on the STM32 here. XX means it can be 6RE or any other number. Then click on SRC. Here you can see we have all the .c files which are provided by the STM32 hall library. For example, external interrupt, flash, GPIO, power, RCC, timer, hall.c and all. So since we are only going to blink an LED, we can double click on STM32F44XX hall GPIO.c, and it will open the GPIO.c library which is provided by the STM32. In the outline window, we can see all the functions which are available or which are provided by the STM. For example, GPIO init for initializing the GPIO, dinit to deinitialize it, read pin, write pin, toggle pin, lock pin, GPIO external interrupt handler, GPIO external interrupt callback. So for time being, we are just going to toggle the LED. Therefore, we will use this function. And here when you click on this function, you can see in the hall library, we go to the same function which we have selected. For example, if you want to go for write pin, click on that, it will take you to the write pin, and you can see what is written inside the function. So we want to toggle the LED, so click on that, and here it says this toggles the specified GPIO pin. And what are the parameters that you have to pass? GPIO X, first parameter, and then GPIO pin. And what can be GPIO X? Here X can be any number between A to K. So these are the port A to port K. So please go through the library before using them. And then GPIO pin, you have to specify the GPIO pin which you want to toggle. So let me copy this function GPIO toggle pin, go to my main, and inside the main we can see we are at the main function, and in the while loop below the user code begin 3 I will paste this code. Okay, now we have to provide the proper definitions for GPIO X and GPIO pin. So how can I get the GPIO X? So I will delete this and use GPIO control space instead of that LED control space GPIO port. So this is the GPIO port for the LED pin, that is PA port A. And then you can just delete this part and just type LED control space LED pin. Or else how can you know what is the GPIO port and GPIO pin? For that you can just go down where you have initialized the GPIO. You can see here LED GPIO port and LED pin. So this is the port name and LED pin name. So that is what we have used, LED GPIO port and LED pin. So this will toggle the LED. But remember, this toggling will be so fast that you will not be able to see the effect on the LED. Because the microcontroller is running at a very high speed. I can show you from here in the clock configuration. You can see the clock is running at 84 megahertz. That means the clock will be, the LED will be blinking at a very high rate. So what we can do is we can introduce a delay. For that you can use hall underscore delay. For that you can just type hall underscore control space to get all the options and click on hall delay. Here specify the delay in milliseconds. So we are introducing a delay of 1000 millisecond. That's all. So you have just written 2 lines to make the LED, that is the LED connected to PA5, or you can say that is the onboard LED. Okay, so here we have made a simple program to make the LED toggle after every 1 second. Now come to the top, click on the hammer button to build the program. After building, you can see the console to check whether the program has been generated without any error or not. And we can see the program finished with 0 error, 0 warnings. Now we can upload the code to our board and see if the LED is blinking or not. So let me just open my camera to show you the microcontroller board and upload the code onto the microcontroller board. I hope now you will be able to see the microcontroller board on the top right. To upload the code, there are 2 options. Either you can use debug mode. Okay, for that you can click on this bug, or you can directly upload the code and run it in a single go by clicking this green button. So I would recommend you to use debug so that you can see the effect of your code and run the code line by line. So it will help you to debug the code if there is any error. So let me click on the bug. And with this we will enter into the debug perspective. Click OK. So you can see first the code was generated using MX, cube MX. Then we modified the code in the C perspective, and now we are going to enter into the debug perspective so that we can debug the program if there is any error and we can see how the program is running step by step. So in the debug perspective, you can see you will get some switches like terminate and relaunch, resume, stop debugging, step into, or step over. So let us see how can we step into. So after this, if you click on step into, it will go through each and every line of the program, and it will go through library to library to library depending on whichever libraries are used by that particular function. Or you can use step over to jump over the functions, or you can just click here step return to go back to your main program. So all init has been executed. Now we can click on step into to finish this function. Otherwise, if you go to step into, it will go line by line through all the functions which are used by the clock config. So I will prefer to step over, and now we have reached in the main while loop. And now I can just click on the step into, and now you can see we have entered into the whole GPIO toggle pin function, and we can see whichever registers are getting used in this while executing this function. If you are not interested, you can just step over and come back to your main program. Okay, here now you will be able to see the green LED on, and step over. After the delay, you return back to the main program, where further we are going to toggle the code. So this make the LED off, delay, LED on, delay, and once you are satisfied with the way the code is running, you can just click on resume, and it will run the code in the board. And you can see the LED is blinking or toggling after every 1 second. With this, you can enter or you can terminate the code and enter into the same C perspective if you want to make further changes. With this, I would like to end this lecture or presentation, where we have seen how to blink an LED using STM Cube IDE and using STM Nucleo F446RE microcontroller board. If you have any suggestions or concerns or doubt related to this video, you can post your suggestions or doubts in the comment section. If you have not subscribed my channel, then I would request you to please subscribe the channel and share it with your friends. Thank you and have a nice day.